As part of the present administration's efforts to curtail the spread of coronavirus COVID-19 ravaging the country and the world at large, Edo State Ministry of Education, in collaboration with Edo Broadcasting Service (EBS) and Academic Staff Union of Secondary Schools (Asuss), is organizing a television program for students in senior secondary schools, particularly those writing the West African Senior School Certificate Examination (WASSCE), the National Examination Council (NECO), and National Business and Technical Examination Board (NABTEB) for the year 2020 in the months of May, June, and July. The program will be held on EBS television channel every day from 12 noon to 1 p.m. beginning from Monday, April 6, 2020. The subjects selected for these programs are Mondays Mathematics, Tuesdays English Language, Wednesdays Physics, Thursdays Biology, Fridays Geography, Saturdays Civic Education and Economics, and Sunday Chemistry. Parents and guardians are therefore advised to draw the attention of their children or wards to this opportunity during the stay-at-home period.
Famous FAUs know one of my names. I'm the instructor for today. Today I'm going to be taking you chemistry. Chemistry, one branch of science. This particular subject is of two types, organic and inorganic. Today I will be taking you the organic aspect of chemistry on the topic hydrocarbon. Hydrocarbon, as the name stated, it is derived from two elements: hydro from hydrogen, carbon from carbon. It therefore means that hydrocarbon is an organic compound that contains hydrogen and carbon only. It's an organic compound that deals with hydrogen and carbon only. Hydrocarbon are mainly gotten from different sources. One of the sources is petroleum, which we refer to as crude oil. Another source of it is natural gas, and the last one is coal. So, petroleum is the major source of hydrocarbon. And every other hydrocarbon compound falls into these various sources. Hydrocarbon is of two classes, namely aliphatic and aromatic. The aliphatic hydrocarbon can either be a straight chain hydrocarbon or a branch-shaped hydrocarbon or a ring-shaped hydrocarbon. The aliphatic hydrocarbon are subdivided into cyclic and acyclic. Like I've said before now, that the aliphatic can either be a straight chain or a branch chain or a ring shape. For the straight chain aliphatic and the branch chain aliphatic, arcades, alkenes, and alkyne falls into the straight chain or the branch chain aliphatic, which we will refer to as the acyclic form of aliphatic. Then we also have cycloalkane. The cycloalkane form of aliphatic is the ring form of aliphatic, which we will refer to as the cyclic aliphatic. The aromatic part of hydrocarbon is the unsaturated part of it. And we have examples like benzene, which is the main backbone of the aromatic. Every other aromatic compound like methylbenzene, which we refer to as toluene, hydroxybenzene, which we look at phenol, benzoic acid, which was able to refer to as benzoic acid, all falls into the aromatic compound. We're going to look at the aliphatic in general. Alkane, which is the main aliphatic compound, has a general formula of CnH2n plus 2. The alkanes also have the general formula CnH2n, sometimes plus 0. Then the alkyne also have a formula CnH2n minus 2, while the cycloalkane have the same molecular formula with that of the alkane, CnH2n plus 0. But most of the time, the 0 does not really have a positive impact to this molecular formula. So as a result of that, the 0 is not necessary. You may either have it as CnH2n or CnH2n plus 0. The aliphatic, which contains the alkane, are highly saturated. They are the saturated part of the aliphatic. That means the carbon bond of the alkane are saturated with 4 single bonds. That means each carbon atom contains 4 single bonds, either in the form of carbon hydrogen or carbon to carbon. An example of alkane having this general formula CnH2n plus 2 is your methane. With C1H4, your ethane C2H6, your propane C3H8, down to decay. If we go with this formula of CnH2n plus 2, where n is equals to 1, meaning the first carbon atom, then we'll have for ethane with C2H6, propane with C3H8, applying this general formula of CnH2n plus 2 will give us the corresponding alkane family, starting from methane down to decay. The first member of this series, methane, ethane, propane, butane, are gaseous in nature. They are gases. And the fifth member down to the 12th member, that is from pentane down to decay, are liquid, and higher member of this family are solid. Alkane, like we all know, are saturated hydrocarbon. For the alkenes, we also have CnH2n, and the first member of the alkene is ethene with a formula CnH2n. If we apply that formula, where n is equals to 1, where n is equals to 2, then we have C2H4. All members of this family of the alkane series are represented in single bonds. The carbon to carbon bond are all in single form. That makes it saturated hydrocarbon. Taking a case study of the structure of methane, you will discover that all the carbon atoms are bonded with single bond. That makes it a saturated hydrocarbon. Having known this, we are going to look at general lab preparation of arcane. The laboratory preparation of arcane are mainly carried out using sodium salt of carboxylic acid, which is also known as arachidonic acid. That is the sodium salt of either carboxylic acid or the sodium salt of arachidonic acid with soda lime. Soda lime is a mixture of sodium hydroxide and caustic soda. Soda lime is a blend between the sodium hydroxide and caustic soda. Both mixed together can give us the corresponding arcane and the sodium salt of the thiazocarbon form. Take a case study of sodium acetate or sodium ethanoate reacting with soda lime. Looking at the reaction between sodium ethanoate reacting with sodium hydroxide, the corresponding sodium thiazocarbon, the first salt, is produced alongside with a gas which is colorless and odorless. And also, the gas is less dense than air. It burns with a non-luminous flame, which we refer to as the methane gas. Every other members of arcane can be prepared using this general formula in the lab. How do we know how arcane can be prepared in the lab? We are going to look at the chemical reactions that can easily be carried out by this family of arcane. Chemical reaction of arcane. Arcane is highly saturated. So because of its saturation, they react in a little form. That is, their reaction is not that too, they react literally. As a result of that, they are called paraffin, meaning little affinity. However, they undergo two reactions, which is combustion and substitution reaction. Arcane carried out combustion reaction, meaning they burn in air to produce two products: carbon dioxide and water. All arcane, in fact all hydrocarbon, burns in air to produce carbon dioxide and water. That is, if the air is sufficient. In a situation whereby the air is limited, it therefore means that instead of having carbon dioxide, we'll have carbon oxide alongside with water. We are going to be taking a case study of combustion reaction of arcane using methane as a case study. Now, looking at chemical reaction that arcane can carry out with combustion, that is burning in air, we discover that carbon dioxide and water are the major products of any hydrocarbon that carry out combustion. Now, in stating this equation, two things you put in mind: the state of reaction. If you don't know the state of reaction, it is better you silent in it by not putting it at all. Anything that makes you have a state of reaction in the reactant and fail to put it in the product, the chemical equation become wrong. So if you are to write a chemical equation, always consider the state if you know it. If you don't know it, just silent in it. Now, looking at the chemical reaction of arcane we said combustion reaction has to do with alkane reacting with oxygen to give a product carbon dioxide and water. Now take a case study of methane reacting with oxygen to give carbon dioxide and water. Looking at carbon here, we have one atom. Looking at carbon here, we have one atom. Oxygen here, hydrogen here is 4, and hydrogen here is 2 times 2, which is 4. Then the total oxygen we have here is 2 plus 2, making a total of 4. Coming down to this place, we are not dealing with atoms, rather we are dealing with molecules, which is gas. Then 2 times 4 will give us 8, divided by 2 will give us 4, which is equivalent to this. Now, in other way around, if you don't want to pass through the process, you can decide to double the molecules of methane that is reacting. Now, looking at this particular equation is also synonymous to this. Just that here we deal with 1 mole of methane reacting with oxygen to have carbon dioxide and water. Then here, to make the equation more simpler, we double the mole. The most important thing in this reaction of combustion is that carbon dioxide and water are the major products that will be formed anytime hydrocarbon burns in air. Burns in plenty supply of air. In a situation whereby the air is limited, we cannot have carbon dioxide, rather we will have carbon 2 oxide. Now, considering the substitution reaction alkane carries out, alkane cannot undergo addition because they are saturated. Rather, they carry out substitution reaction. Reacting with halogen, picking chlorine gas as a case study. Then this reaction will give us, this reaction can only be carried out in the presence of light. Light acts as a catalyst for this reaction to be carried out to form trichloromethane. To form chloromethane. To form chloromethane. Light. Because light is involved as a catalyst, this reaction is referred to as photocatalysis. Photo means light. Why the light serves as a catalyst to make the reaction process to be fast. So in the absence of light, this product will not be what? Produced. And the reaction process will be in a continuous form until all the hydrogen atoms in the alkane are fully substituted by the chlorine atom. UV is same thing as light. And the 4 possible products that will be formed whenever alkane, which is for example methane, reacting with any halogen compound. Taking chlorine as a case study, we are going to be having chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. These 4 possible products are what we are expected to have whenever alkane is being halogenated. In absence of chlorine, iodine can also be used. Where you have chloromethane, if iodine is used, it becomes iodomethane. Where you have dichloromethane, if iodine is used, it becomes diiodomethane, triiodomethane, and tetraiodomethane. Chloromethane is also known as chlorophyll, while iodomethane is also known as iodophile. Having known this, where can this be applied? That will take us to the uses of alkane. They are used mainly as fuel. Taking a case study like methane, which can be used in the production of water gas. an industrial fuel. And also, they can be used as domestic gas, that is our cooking gas. Butane, for example, is recommended as our cooking gas. So they serve as fuel. Fuel means anything that burns to release heat energy. And aside that too, octane, which is also a member of alkane, can also be used as a starting material in the production of petrol. And whenever octane is being break down during the process of cracking, ethene, which is another important raw material in the production of polyethylene, can also be produced from this alkane series. Another use of alkane is that when they are being halogenated, they will either form either the chloromethane or iodomethane, dichloromethane, and so on and so forth, which can serve. Chloromethane, for example, is used mainly as an anesthetic. Iodophone, which is iodomethane. Chloromethane, which is also known as chlorophone. Chlorophone is used as an anesthetic, while iodophone is used as germicide in treatment of skin bacteria. Uses of alkane, like we also know, alkane is used mainly for fuel. Like the butane, for example, is mainly used for domestic cooking gas. Methane can also be used in the production of water gas, which can also serve as industrial fuel. And also, octane is also a fuel, but when being reformed, it becomes a fuel with high octane number, which is referred to as petrol. And also, whenever octane is being cracked or higher member of alkane is being cracked, then ethene is also gotten from it, which can also serve as a starting material in the production of polyethylene and PVC, that is polyvinyl chloride. Also, alkane can also be used as anesthetics in the medical field, especially in the hospital. It can also be used for the production of germicide. Alkane that is used for anesthetic are referred to as chlorophone, trichloromethane, and the alkane that is used for germicide are triiodomethane, known as the iodophone. Then tetrachloromethane is another important organic solvent that can be used in the production of so many things. Organic solvent can be used in the production of paints, can be used in the production of so many things in the industries that has to do with production. Uses of alkanes are what we have on the board that you can easily take note of. Having known this, we are going to look at some likely examination questions under this topic. Question number 1. Give 2 properties why soda lime is used instead of caustic soda in the preparation of methane. The B part of it lists 2 physical properties of methane, and the C part of it gives 2 uses of alkane. Now, looking at the first question, properties why soda lime is used instead of caustic soda. In the reaction of alkane, we said it's a reaction between sodium salt of carboxylic acid reacting with soda lime. Soda lime is a blend, a mixture between sodium hydroxide and calcium oxide. Have it in mind that calcium oxide, which is also known as quicklime, is a good drying agent. And sodium hydroxide is a good deliquescent compound. That means sodium hydroxide can easily absorb moisture and turn into solution. That is what deliquescent is all about. For the sake of sodium hydroxide not turning into solution, calcium oxide is added in blending. So to answer that question, why soda lime is preferable to caustic soda, is that soda lime is not a deliquescent compound. And number two of it is that soda lime does not attack glass. So caustic soda can easily attack glass, and caustic soda is also deliquescent. For the sake of not experiencing that in the chemical reaction setup, that is why little of calcium oxide is added to the caustic soda, which we refer to as a soda lime. Then to answer the second question, the physical properties of methane. Okay, methane is a colorless and odorless gas. In the reaction setup, a colorless and odorless gas will be evolved, which is one property of methane. And aside that, methane is less dense than air. And whenever methane burns in air, they burn with a non-luminous flame. All this one can serve as a properties for alkane, usually methane. Then we have to give two uses of alkane. Yes, two uses of alkane. Alkane are used mainly as fuel. Like we all know, we say our domestic gas, which is mainly of butane, is used. It's from alkane, and they are used in cooking. And aside that, our water gas, which is one major important industrial fuel, is also from alkane. Then another use of alkane again is that halogenated form of it, which what we have iodophone and chlorophone. Chlorophone, we all know, they are mainly used in the chemical and pharmaceutical industry, especially in the production of anesthetics. And also too, iodophone, which is also used in the production of germicide. Trichloromethane, another use of alkane, can also be used in the production of organic fuel. That will answer your question on the first. Now we're also going to look at another question again, question number 2. Write the general formula of 1 alkane, Roman figure 2 alkenes, and Roman figure 3 alkyne. The big part of it, name the products of combustion of hydrocarbon. And the last part of it, which is the C part, is write balanced equation for the combustion of ethane and propane. Now, let's look at the first question. Write a general formula for alkane, alkene, and alkyne. Alkane has a general formula of CnH2n plus 2. Alkene has a general formula of CnH2n, and alkyne have a general formula of CnH2n minus 2. That answered the general formula for alkane, alkene, and alkyne. You are asked in the big part to name the products of combustion of hydrocarbon. Like I've said in our class, that whenever hydrocarbon burns in air, in supplies of air, plenty supply of air, two products are likely going to be produced, which is water and carbon 4 oxide. Hydrocarbon has this formula CX. Sorry, the products from our reaction is, looking at this general equation for all hydrocarbon each time they undergo combustion, you saw that carbon 4 oxide and water are the products of hydrocarbon. Looking at the third question, write a balanced chemical equation for the reaction of ethane. Ethane is a good example of hydrocarbon. First, you have to look at the formula of ethane, which is C2H6. C2H6 C2H6, which is the formula for ethane, undergoing combustion to give you carbon dioxide and water. They are saying a balanced chemical equation. That means the atoms you have in the reactant side must be the same with total atoms you have at the product side. If you don't know the state of reaction, it's better you silent in it rather than putting a state of reaction that is incorrect. Now, ethane is a gas. Ethane is a gas, oxygen is a gas, that is gas molecule, carbon dioxide is a gas, and water is a liquid in their physical state. We have 2 carbon of atom in ethane at the reactant side, and we have 1 carbon of atom at the product side. For the sake of balancing, we'll make this one 2. We have 6 atoms of hydrogen in the reactant side, and we have 2 atoms of hydrogen in the product side. For the sake of balancing, we'll make it 3. That means 3 times 2 will give us 6 atoms, which is equivalent to what we have in the reactant. 2 times 1 of carbon will give us 2, which is equivalent to what we have here in carbon. Then, looking at the oxygen in the product side, 2 times 2 is 4. 3 times 1 is 3. 4 plus 3 will give you a total number of 4 plus 3 will give you 7, which is total number of oxygen. And here we have 2. To make this equivalent to this, what we need to do is to put 7 here and put 2 here. That means 2 times 7 will give us 14. When you divide 14 by 2, will give you 7, which is equivalent to the total number of oxygen you have at the product side. Then for propane, propane is C3H6. Because from the formula CnH2n, it means that N is 3. So 3 times 1 is 3. Then 2 times 3 will give us 6. That's the formula for propane. Propane reacting with oxygen, the product is always carbon dioxide and water. Let's look at the balancing. Their states: gas, liquid. Like I've said, if you don't know the state, you are not sure of the state, don't bother to write it. Just leave it like that. Rather than putting a wrong state that will affect the equation. We have carbon 3 here, 3 carbons here of carbon, and 1 atom of carbon. For the sake of balancing, we'll put 3 here. Hydrogen here is 6, and hydrogen here is 2. For the sake of balancing, we'll put 3. 3 times 2 will give us 6, which is equivalent to 6 hydrogen. 3 times 1 that we have here is 3, which is equivalent to 3 atoms of carbon at the reactant aspect. Now, the oxygen have increased. 3 times 2 will give us 6 oxygen. 3 times 1 will give us 3 oxygen. 3 plus 6 will give us total number of 9 of oxygen atoms at the product. And here we only have 2. So to make it balance, we simply write 9 over 2. Meaning 9 times 2 18. 18 divided by 2, 9, which will give you exactly what you have at this point. Now, for those of us who will always find this difficult to balance, you will increase the number of mole of the reactant. By increasing the number of mole, you are going to have a whole number which will be easier for you to balance. The most important thing is knowing the product that is formed, which is carbon dioxide and water. Once that is known, then the balancing becomes easier. I hope that is clear. We said hydrocarbon are organic compound that deals with carbon and hydrogen only. Ethanoic acid, phenol, benzoic acid, arachidonic acid, carboxylic acid, they are not hydrocarbon, rather they are derivatives of hydrocarbon. Why do we see them to be derivative of hydrocarbon? It's because they contain more than 2 elements. In arachidonic acid, we have 3 elements: carbon, hydrogen, and oxygen. From our definition, we said hydrocarbon is organic compound that contains carbon and hydrogen only, nothing more. So, as a result of that, arachidonic acid, carboxylic acid, alkanol, they cannot be called hydrocarbon, rather they can be referred to as derivatives of hydrocarbon. And we said the source of hydrocarbons are crude oil, natural gas, and coal. And the major source of hydrocarbon is the crude oil, which we all know. And we said the classes of hydrocarbon are of 2 types: the aliphatic and the aromatic. The aliphatic part of the hydrocarbon are either straight chain or branch chain, which is what we refer to as the open aliphatic. And the cyclic part of aliphatic, which also refers to as the closed ring aliphatic. The cyclic form of aliphatic, they are not unsaturated hydrocarbon. The aliphatic are saturated and unsaturated. The saturated part of the aliphatic is the alkane, while the alkene and the alkyne are both unsaturated. The cycloalkane, although it has a ring structure, that does not mean it is an aromatic compound. What we use in defining aromatic compound is benzene. All aromatic compounds must have a benzene backbone in their molecule. If benzene is not there, we cannot refer to such compound as aromatic. So cycloalkane is an aliphatic because all the carbon bonds are all simply bonded. They have a single bond. That is, all the carbon atoms are saturated with a single bond. So that is why cycloalkane is not an aromatic compound. Okay? And we said that alkane have a general formula of CnH2n plus 2. Alkane have a general formula of CnH2n, while the alkyne have a general formula of CnH2n minus 2. These formulas are very important as long as the formula of all respective members of alkane, alkene, and alkyne are concerned. Okay, and with a molecular formula, it will be easy for you to represent the structure, because the formula are meant to design the structure of either alkane, alkene, or alkyne. And we said in the lab, alkane generally can be prepared whenever sodium salt of arachidonic acid is allowed to react with soda lime. From our class, we said soda lime is a mixture of sodium hydroxide and calcium oxide. In this reaction, sodium hydroxide is the main anti-inhibitor. Although calcium oxide is added, the calcium oxide is just acting as a drying agent. Calcium oxide is also called quicklime, in case you are asked. And we said, at the end of the day, sodium salt of triazole carbonate 4 and the corresponding alkane are produced. I will take a case study of sodium ethanoate. which can also be called sodium acetate. Sodium acetate is old name for sodium ethanoate. If you go to the market, you want to go for this salt, you might not see it as sodium ethanoate because the companies that produce most of this salt, they use old name, which is referred to as sodium acetate. Sodium acetate is the same with sodium ethanoate. So whenever this salt is allowed to react with sodium hydroxide, then sodium triazocarbonate 4 and the corresponding alkane are produced. We said the reaction that can be carried out by alkane, because they are saturated hydrocarbon, is combustion and substitution. Alkane cannot carry out addition reaction because they are already filled up. You cannot add to them. So because of that, they are being substituted for. And reacting with halogen, a family of halogen can either be fluorine, chlorine, bromine, and iodine. In this reaction, fluorine is not allowed. Fluorine is very reactive. So because of the reactive nature of fluorine, we prefer using chlorine in carrying out this reaction. And this reaction, like we all know, is photocatalysis. It means that the reaction must take place in the presence of light. Light is a catalyst. Without light or without UV, the reaction will not take place. Take note, if this reaction is being spelled out without the presence of UV, know that the reaction will not hold, will not be possible. This reaction can only be possible in the presence of light. And that is why we refer to this reaction as photocatalysis. Wherever chlorine is allowed to react with methane, 4 possible products are likely to be formed, which are chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. At this junction, I will expect you to take close recognition of hydrocarbon, the difference between hydrocarbon and the derivatives of hydrocarbon. Derivative of hydrocarbon contains oxygen, while hydrocarbon in question contains only carbon and hydrogen. I hope you all got this information. Till I come your way next time, I urge you to stay away from trouble and be a good citizen of the Federal Republic of Nigeria. God bless you.